When I say battery, what pops into your head? Probably a little metal cylinder, right? Full of all sorts of complex chemicals. But what if we could store tons of energy in something way simpler? Something almost ancient? What if we could store it in just pure, simple motion?
I know. It sounds a little bit like science fiction, doesn't it? But this idea, it gets right to the heart of one of the biggest energy challenges we're facing today. So let's dig in and see how this incredible concept could actually work.
Just think about it for a second. Every time you hit the brakes in your car, or on a train or a bus, all that forward momentum, all that energy, it has to go somewhere, right? Well, right now, most of it just turns into useless heat in your brake pads, and poof, it's gone. Vented out into the air. It's a massive, massive waste of energy.
And this problem is so much bigger than just our cars. We're talking grid scale here. We can generate tons of clean power from wind and solar, but storing it so we can use it when we actually need it, that's kind of the holy grail of renewable energy. So how do we tackle both of these huge problems, the wasted energy on our roads and the unreliability of our grid? Well, the answer might be literally spinning right in front of us.
Yeah, we're talking about a technology that's been around for thousands of years, but it's been totally reimagined, supercharged, really, with some amazing 21st century science. We're talking about the flywheel.
I mean, just look at the evolution here. It's absolutely incredible. On one hand, you've got the good old potter's wheel, basically a heavy stone disc that uses its own momentum for a nice, slow, steady spin. And on the other hand, wow, you've got its modern descendant, a super sleek rotor made of advanced carbon composites, spinning faster than a jet engine, designed to store just a mind-boggling amount of energy.
And the basic physics behind it? Honestly, it's beautifully simple. It's all about kinetic energy. The more stuff you have spinning, and the faster you spin it, the more energy you're cramming into that motion. A modern flywheel just takes that very simple idea and pushes it to the absolute extreme.
Okay, so how does this whole cycle actually play out? Well, it's this really elegant three-step dance. First, you accelerate it. You use electricity, maybe from the grid, maybe from a solar panel, to power up a motor that spins this thing incredibly fast. That's charging. Then step 2, store. You just let it spin in this super efficient environment, holding onto all that kinetic energy. And finally, when you need that power back, the motor flips its role and becomes a generator. The flywheel's momentum now powers the generator, creating electricity as it slows down. So you've got accelerate, store, and release. Simple as that.
Okay, but hold on. How in the world do you get something to spin at over 100,000 RPM without it either just shredding itself to pieces or losing all its energy to friction? Well, that's where some truly incredible engineering comes into play. Let's take a look inside. It really comes down to 4 key pieces of tech. First, the rotor itself. It's not just a chunk of steel. It's made from these super high-strength composite materials like carbon fiber that can handle unbelievable forces. Second, the motor and the generator are combined into one super efficient little package. And then there's the third and fourth, and this is where it gets really, really clever, the magnetic bearings and the near-perfect vacuum chamber.
See, this really gets to the core of it. For anything that spins, you have 2 major enemies: friction from the parts that are touching and drag from the air itself. So what do modern flywheels do? They solve both problems brilliantly. They use magnetic bearings to levitate the rotor, so it's literally floating on a magnetic field. Nothing is physically touching. Then, they seal the whole thing inside a vacuum. It's about as close to a totally frictionless world as we can create here on Earth.
All right, so we've got this amazing piece of technology. So what? What can we actually do with it? Well, this is where it gets really, really cool, because we're starting to see these mechanical batteries out in the real world doing some amazing things. And the uses are all over the place. I mean, for the main power grid, they can react in just milliseconds to balance things out and stop a blackout before it even starts. In transportation, they capture all that wasted braking energy from things like trams or even EVs, making them way more efficient. They can take the bumpy, inconsistent power from a wind farm and smooth it out into a steady stream. And they can provide rock-solid, uninterrupted power to places that absolutely cannot fail, like data centers or hospitals. And get this, they do all of this with a round-trip efficiency of over 90%. That's amazing. It means for every 100 units of energy you put in to spin it up, you get more than 90 back out. We're talking efficiency that's right up there with the very best chemical batteries we have today.
So where do we go from here? What's the future of spin? Let's take a quick look at how it stacks up against the competition.
Now, when you put them side by side with, say, a standard lithium-ion battery, you really see where flywheels shine. First off, lifespan.
It's not even close. A flywheel can be charged and discharged hundreds of thousands, maybe even millions of times with barely any wear and tear. They also deliver their power in a massive, sudden burst, which is exactly what you need for something like stabilizing the grid. Now, they're not meant to replace every battery, but for jobs that need huge power and a super long life, they're just in a league of their own.
Of course, the tech isn't perfect yet. Even with all that clever engineering, there are still tiny energy losses. Engineers call it self-discharge. It basically means the flywheel will very slowly lose its speed over hours or days. The big challenge for researchers right now is to get that number as close to zero as possible to make these things even more frictionless.
So, as we're racing to find better, greener ways to power our future, it's pretty amazing to think that one of the most promising solutions might not be some brand new chemical breakthrough, but the absolute perfection of an idea that's as old as pottery itself. Just the simple, powerful, and kind of beautiful physics of a spinning wheel.